Hi, I'm René Schäfer and I present the work on What's That Shape? Investigating eyes-free recognition of textile icons. For this, I worked together with Oliver Nowak, Lovis Suchmann, Sören Schröder and Jan Borchers. Textiles are all around us and offer interesting places to add new functionality to our existing environment. This becomes especially interesting when dealing with smart homes. But how should textile interfaces and their components be designed? Can users still use them confidently when they cannot see the widget but only feel it? An example scenario would be a textile interface on the side of a chair or sofa. In our previous work, my co-author Oliver Nowak, myself, and other colleagues already investigated the design of textile sliders. This work now deals with icons, as known from classical GUI implementations, but applied to textile surfaces. We wanted to see whether people are able to quickly identify common shapes using touch alone. Previous work already showed that shapes which are simply embroidered on a textile surface are rather hard to be identified via touch alone. Do raised or recessed shapes perform better than flat icons? Does it matter whether the varying height affects the whole shape or just its outline? With this, we created 6 variants, which you can see on the right. Brown resembles MDF that we use to realize the height change, while blue is simple yarn. Raised filled icons have a raised inner shape. Raised outline icons use MDF to only raise the outline. Recessed icons are basically the inverse of their raised counterparts. Recessed filled icons raise everything except the icon shape, while recessed outlined icons raise everything except their outline. Flat filled icons have the whole icon shape embroidered with yarn, while flat outlined icons only have their outline embroidered. In our work, we investigated 14 commonly known shapes. We only include shapes that could be drawn with a single stroke where no lines crossed. Together with our 6 fabrication variants, we therefore created 84 different textile icons. We created our icons by using MDF as an infill for the height. For this, we created templates using a laser cutter, stitched an outline on the fabric, glued the template in place, and laid another layer of fabric on top. All sewing was done using an automated sewing machine. The templates had to be precise, such that the sewing machine did not take any damage from the MDF. All icons were 18 by 18 mm in size, and the height difference for raised and recessed icons was about 1.6 mm. Here you can see the moon shape in all 6 fabrication variants. From left to right, we have raised, recessed, and then flat icons. The upper row shows the icons where the height was applied to the whole shape, while it only affected the outline in the lower row. To test our icons, we conducted a user study with 42 participants and used the within subjects design. Our participants had to identify given shapes without looking. We measured the recognition time and correct and wrong recognitions. Additionally, participants filled out multiple Likert scales and provided a final ranking regarding our fabrication variants. Our study setup consisted of a monitor that displayed all possible shapes in between recognition trials. With this, participants were aware of all possible shapes. However, we turned the monitor off during each trial to avoid simple pattern matching. The participants had to press a button, then identify the shape that was placed on Velcro next to it, and press the button again. Afterward, they named the shape. We provided no information to them whether they deduced the icon correctly. Overall, participants had very high recognition rates in both raised conditions. Many icons were also identified in more than 95% of the cases. Recessed filled icons performed only slightly worse compared to raised icons. Recessed outlined icons still had recognition rates of above 79%. Flat icons, on the other hand, performed rather poorly with less than 60% correct recognitions. Additionally, participants needed significantly more time to identify the given shapes. On the left, you can see shapes that performed particularly well in both raised variants, with more than 95% correct recognitions. On the right, you see shapes that did not work throughout any of our fabrication variants. Using Likert scales, We asked our participants on their mental demand during the task, how easy it was to recognize the rough shape and respective details, how confident they felt regarding recognitions, and more. Here's an example for one of our Likert scales, where we asked the participants how confident they felt when identifying shapes. Both raised variants received similar scores and were generally liked. Recessed filled icons were also given rather positive scores. Recessed outlined icons received mixed results, and flat icons do not support confidence at all. Overall, the results for all of our Likert scales were very similar. Raised icons were given high scores. For recessed icons, the filled variant was usually more similar to the raised icons. Flat icons received low ratings across all categories. During the study, confusions happened where a participant mistook a shape for another. Interestingly, such confusions mainly occurred in one direction. For example, for raised filled icons, the plus shape was confused 9 times for the star, while this did not occur once in the opposite direction. One confusion that surprised us was between heart and arrow in our flat filled fabrication variant. Here, heart was mistaken for arrow 9 times as well. The lightning shape had rather low recognition rates throughout our study. We cannot recommend using it in its current form. With our findings, we provide the following recommendations when using textile icons. Use raised icons if possible. Choose recessed filled over recessed outlined icons. Flat icons are only useful when they are visible during the interaction due to their low saliency. Prefer simple shapes, as participants could identify them confidently. We also tested whether our fabrication process works for other fabrics as well. For this, we tried using various different materials, and the results look promising. For more information, please refer to our paper.